Okay, so this one might look really complicated right now, but assuming that I can explain it to you relatively well, it's not actually as bad as it looks. So, first, I need to show you what's going to happen to the graph and function of a quadratic equation when it has a vertical shift, a horizontal shift, a reflection on the x-axis, and a vertical stretch or compression. First of all, we're going to use the basic quadratic equation y equals x squared, and we're going to base all of the shifts and the reflection and stretch or compression off of that equation. And second of all, I actually did a stretch and a compression, so I can show you both of those. Okay, so, excuse me. The basic quadratic equation, y equals x squared. I graphed, so both of these are red, but they kind of like show up differently on the graph. So y equals x squared, that's this one that's dead center in the middle. And it's a little bit darker than this one. I don't know if you can really see that, but this is the basic equation. So all of these different equations and lines, they're all going to be based off of that. So we're going to start with a vertical shift. And when it shifts vertically, that means it's going up or down. For this one, we're going to go down. So I feel like the best way to show you this is showing you like the other equation that's kind of based off of, and that is the vertex form of a quadratic equation, which is y equals a times x minus h squared plus k. Okay, so this minus 1, it's not in the parentheses or anything, it's just this plus k. And when the number that's like in this equation is part of the k, that means that it's going to have something to do with a vertical shift, because this is kind of like what's going on the y-axis. So because it's a minus 1, it's going to go down 1. So y equals x squared minus 1 correlates with this purple parabola right here. For the next one, it's a reflection, or no, it's a horizontal shift. So we used y equals x plus 1 squared. So that plus 1 is like the key of the horizontal shift, which is this h here. So because it's positive, it's technically, like for the vertical shift, it's a negative, which means it goes down. So you would expect that this being a positive, that it would go like forward. But it goes backwards because it's actually a negative one. But since this part of this equation is a negative, it's like a negative times a negative, which gives you that positive 1, if that makes any sense at all. So if it's positive, it's going to go backwards, and if it's a negative, then it's going to go forwards on the graph. So because this is plus 1, it's going backwards 1, and that's this other light red parabola. Again, I don't know if you can see the color difference between this parabola and this standard one, but it's there. Okay, for the next one, this one's a reflection over the x-axis. So I guess a reflection over the x-axis is kind of like what the a is, like a slope kind of, if that, yeah, that makes sense. So if it was like -2, then the slope would just be, it's just like the same thing except switched if it's a negative. So because it's a negative x squared, it looks like the same thing as this but with negative, right? So notice how this standard equation makes this parabola negative x squared. It's the same exact thing except upside down. So if we did like, for this one, y equals x squared minus 1, and that's this equation, that's this parabola. If that was y equals a negative x squared minus 1, then the parabola would look exactly like this with the same slope and everything, except upside down, but the vertex would still be at this point. For the next one, this is a vertical compression. So the equation is going to be y equals 1/2 x squared. So the way you know if it's a compression is if the A or whatever's in front of the x is less than, I think it's less than 1. So if it's less than 1, it's going to be a compression. If it's more than 1, it's going to be a stretch. So because this is less than 1, it's like half the slope of our standard equation here, our standard parabola. So that's the blue one right here. Because compression means it's like being pushed down. So like imagine if you like push something down, it's going to kind of like separate that way. If that makes sense. I don't really know how to explain this. So it's gonna like expand while it's being pushed down, because it's not like you're like making any of it disappear, you're just like moving it around, right? So that's why this is gonna be basically the same as the red one, except it was pushed down, it was compressed, so it also opened up more. For the last one, it's a vertical stretch. So the equation is gonna be y equals 2x squared. Again, you know it's a stretch because the a is more than 1. So imagine it's like being pulled from the top, so it's gonna like thin out while you're pulling it. Like imagine you're playing with slime, right? And you pull it apart, it's gonna like get thinner and thinner while you keep pulling it. So that's basically what's happening here, but like more mathematically, in more mathematical terms, it's gonna go, the slope is 2, imagine that over 1. That means it's going to go up 2 over 1, up 2 over 1.